So let us continue with giving another example on how to use semaphores to solve the bounded buffer problem, the producer-consumer problem. And this is a generic code stub, which basically shows you the put and get methods in a producer-consumer setting. You first initialize your buffer, your bounded buffer, to be of the size max. You initialize a variable to be to indicate if it's full or not. Initialize another variable for usage basically, and fill and use will be basically your pointers in the buffer to how much data have you produced, how much data is filled in already in the buffer, and also to how much data is you have consumed from the buffer. So if you look at put first, you basically put some integer value. So you start by filling the buffer from the pointer fill. So fill points basically to the first element in your buffer, which is in this case 0. So you put in the buffer in the first position, in position 0, value, okay, and then you increase fill by 1. So fill plus 1 will basically make your pointer move to the second element in the buffer, so that if you are going to put another element in the buffer, you will basically be able to you'll be pointing to the next element. And then you take the modulus, this fill plus 1 modulus of max, because once you reach the maximum number of elements in the buffer, you want your pointer to wrap around and start from the first element again. Of course, this code can cause issues if you fill the buffer too quickly and you do not consume, or you do not get data from the buffer, emptying the buffer quick enough. You can basically overwrite your data. So this is not perfect code in any way. And then get is quite similar. So you start by getting the first element in the buffer, pointing to use basically. So if this is your buffer, then your use pointer points to the first element because it starts from 0. Once you grab the first element, you try to grab the second element, use plus 1 modulus max again, because then when you reach the end of the buffer, when you have consumed everything that was in the buffer, you can basically wrap around and start from 0, and then you return the value, that whatever value you have been able to get from the buffer. So this is basically how you would implement the bounded buffer using a binary semaphore. You will initialize an empty and full semaphores, which are similar to the conditional variables, and you initialize the empty semaphore from 0 to max, basically saying the empty semaphore basically is the semaphore that says how if you have any empty slots in your buffer. So if you initialize it from 0 to max, that means that, well, you have the first element, okay, and then until max minus 1, you have basically when you reach max, you no longer have any empty slots in your buffer. You initialize full to 0, and that's basically because it's quite similar to how we did the child parent wait implementation, as we will just see. This will be your producer code, where you will basically produce data, again going into like loops is basically the number of data elements that you're going to produce and store in the conditional in the bounded buffer. When you start, you wait on empty. So do you have any empty spaces? Yes or no? If no, then you need to wait. If yes, then you can basically do what, as we said, you will reduce empty, okay, because empty has a maximum number of max, and you basically proceed in your code. The producer will look like this. It will wait on full. So if there is nothing in the in the bounded buffer, if there is nothing in the buffer, you want to wait until something comes in. And since you start from 0, you will see how this will help you here. So this is a binary buffer, binary semaphore again. You initialize empty to 1, max is initialized to 1, and as we said, you set full to 0 as semaphores. You start with both threads sleeping, and then you start from the consumer thread. So the consumer thread comes in, tries, I mean, while temp is not equal to -1, it's like while 1 basically. It's you, but since you do not change temp in this code, you can change it I mean, you can change it if you want this loop to break, but in this loop, you don't change the MP at all. So while temp is not equal to -1, you wait on full. So you're going to reduce full by 1. You're going to subtract 1 from full, decrementing it to -1 basically. So it was 0 here. You decrement it to -1 because this is the wait goal. So now, is semaphore full less than 0? Yes, it is. So that means that the consumer thread needs to go to sleep, and the producer thread can wake up. The producer thread starts basically by calling the semaphore wait on empty, basically decrementing empty by 1. So now empty is equal to 0. Is 0 less than 0? No, 0, because as we said that if it's a negative number, then the thread will have to hold. But now it's not a negative number, it's just 0. So it continues, it puts an element into I, it puts element I into the buffer, sorry, and calls post on full. So now full will be incremented by 1, okay, and now full is equal to 0 and empty is equal to 0. Now still the producer is running, it calls wait on empty, okay, decrements it by 1. Now empty is equal to -1, which basically means that you cannot proceed because -1 is less than 0. So producer goes to sleep, consumer starts, calls wait on full. Okay, so sorry, it returns from the wait call on full because this is the signal from the producer basically to the consumer. It calls getting the element from the buffer, and then posts to empty. So now it has consumed whatever data was on empty. Now the post gets empty to 0, and now the consumer can print whatever it had, and it goes back to the while loop and it sleeps. Okay, the scheduler basically decides to schedule something else. Now the producer starts running, calls wait on empty. Empty has just been changed to 1, right? So now the producer can so if you sorry, empty has over here changed to 0, prints, and